Hey, are we live? Yes, we are. It says upcoming, but no, it's should be happening. Hopefully, just a bit of a delay on the network or something. There's no play. Do it again. Oh, now it's playing. The delay or something. Just checking my sound. Not actually monitoring the sound, so I can remove those. Doing. Yeah, I can't get rid of the YouTube studio thing because the OBS API doesn't have everything I need. For example, share button, which could be very handy. Normally just posting on a Twitter and LinkedIn. Someone joined in, you can say hello. Still posting on LinkedIn. If you want to join the stream, I can open a Zoom chat as well. Or what was I using yesterday? Was it got one of those streaming things for gamers? It was actually pretty good, but yeah, very gamified as it should be. You have lots of options as opposed to LinkedIn, which even going live stream is yeah, not very uh, user friendly. So we're doing that competition, a Kaggle competition on American Sign Language fingerspelling recognition that's using TensorFlow. So we have ChatGPT to help us out or try helping us in this code. When I open it again, I don't want to run certain things multiple times. There is this, not an error. I assume orange is just not critical. Whatever, what's called, just notification. That should be running okay. Now training the model. Yeah, this should take 10 seconds or so. Yeah, 6 seconds. Yep, that's the version of TensorFlow and MediaPipe that we use. What was that? Right, just opening the train, the what's called the ground truth. This is the file that describes each file, which phrase it has. So each Parquet file will hold the locations for. Do I have? Oh, my live is delayed by. It's not too bad. It's only a second or two, but no, it's like 5 seconds. That's okay. Anyway, so someone sign spelling these phrases. There's lots of different participants. Don't know if there's any. Yeah, one thing to check. I don't think this code does it. But if there's any major difference between participants, that's just something to keep in mind. Then quick basic test exploration. So we have the training CSV, the Parquet file. The Parquet file will have the coordinates for each finger. It will also have a Z, X, Y, and Z. But it says do not use the Z coordinates because they are wrong. Something. Well, because there will be nans mostly. Now there will be coordinates for all the recording time, and if there's nans, meaning that hand is not visible or that finger, the digit is not visible, like over here. So face is there, but probably right hand is not in the screen. It's not visible. Yeah, that's the description for each landmark. 21 key points on the hand, and you have it for each. And there's a code to determine which hand is used. So supposedly, my understanding is that when you spell individual letters in American Sign Language, then you might, if one hand gets tired, then you swap to the other hand, and there's a code that determines that. So that's all example code. We haven't changed much there. We did run the training. It took some time. It wasn't optimized, it wasn't running on my GPU, it was running on the CPU. So it's something in the future that we have to address. By the way, side note, my GitHub Copilot trial ends tomorrow, and I decided not to pay for it. So I'm also comparing it today. This is probably the last day that I can really compare it to other tools, one being Tab 9, another is Captain Stack. So Captain Stack will just search Stack Overflow. Stack Overflow, and will give you results. So and will give, as opposed to ChatGPT's GitHub Copilot, it will actually give you a reference to the code in Stack Overflow that is being used. So it's quite handy. For example, this code here is also on it's online, it's referenced, so you have to reference everything you use. It's common practice, something ChatGPT does not do at all. In the past, it will give you references, but not anymore. So I wonder. Yes, and this is ChatGPT 3. Yeah, it will still giving me probably error messages tomorrow saying activate Copilot. You're missing out on all this great code that we just scraped from somewhere without acknowledging. The OpenAI.com, the chat, has a new option to actually share link to this chat, which is quite handy. So I'm using the free version. And let's see. So this competition just came out, but there were similar competitions before. So if we place this, let's just chat to ChatGPT.
Recognizing American Sign Language, ASL, fingerspelling using TensorFlow can be an interesting project. TensorFlow is a popular deep learning framework that can be used for various machine learning tasks, including image recognition. Here's a general overview of how you could approach building an ASL fingerspelling recognition system using TensorFlow. Data collection. Start by collecting a dataset of ASL fingerspelling images. You can search for publicly available ASL datasets or create your own by capturing images of different ASL fingerspelling gestures. Make sure to label each image with the corresponding letter or word. Data preprocessing. Preprocess the collected images to ensure they're in a consistent format and size. Common preprocessing steps include resizing, normalization, and converting the images to grayscale.
So I think this was already done for us. So you don't get, for this Parquet file, you don't get the whole image. It's not video. You just get the coordinates for each finger. And this should be sorry for that. This should be. Save it. Just one sec. Give me a second. I want to share. Share. How do I share? Is there option to share? You can feel this microphone. It's getting a bit warm or something. No, it can't be. No. And that reprocessing. Where were we?
Data preprocessing. Preprocess the collected images to ensure they're in a consistent format and size. Common preprocessing steps include resizing, normalization, and converting the images to grayscale. Data augmentation. To improve the model's performance and generalization, augment the dataset by applying various transformations to the images. This can include rotations, flips, and shifts, which can simulate different hand orientations and positions. Model architecture selection. Decide on the architecture for your TensorFlow model. Convolutional neural networks, CNNs, are commonly used for image recognition tasks and can be a good starting point. You can choose existing architectures like VGG, ResNet, or design your own architecture. Model training. Split your dataset into training and validation sets. Feed the training data into your model and optimize the model's parameters using a suitable loss function and an optimization algorithm like stochastic gradient descent, SGD, or ADAM. Monitor the model's performance on the validation set and adjust hyperparameters accordingly. Model evaluation. Evaluate the trained model on a separate test set to measure its performance. Metrics like accuracy, precision, recall, and F1 score can be used to assess the model's effectiveness in recognizing fingerspelling gestures. Deployment. Once you're satisfied with the model's performance, you can deploy it in a real-time application. This can involve building a user interface where users can input an image or use a live video feed to capture their fingerspelling gesture. The deployed model will process the input and provide the predicted letter or word. It's worth noting that building an accurate and robust ASL fingerspelling recognition system is a complex task. You may encounter challenges related to dataset quality, class imbalance, overfitting, and generalization to different hand shapes and orientations. Therefore, thorough experimentation, iterative improvements, and potentially incorporating advanced techniques like transfer learning or recurrent neural networks can be beneficial. Remember to refer to TensorFlow's documentation and explore relevant tutorials and resources to gain a deeper understanding of implementing image recognition models using TensorFlow.
Yeah, so we trained it already with this code and we got to a loss function of 0.5. This when it starts, what's it? Is it overfitting? So interestingly enough, the training loss keeps going down, but the validation loss stops going down, which is not great. I think we're using like an 20-80 split. Oops. It's a 20. Can't find it. .8. Right, 80% of the data is used for training. We'll leave that comment there. So do we have to, I don't get, do we have to run the code from scratch? And how do we, can you copy just the code? IP1B is a Python TensorFlow Jupyter, the Jupyter notebook. How did it know the file name? That's creeping me out. What link? It's talking about the link.
To provide you with a practical example, I can guide you through the process of building an ASL fingerspelling recognition system using TensorFlow in a Jupyter Notebook.ipim. Please note that the following code is a simplified version for demonstration purposes and may require further optimization and adjustments for a production-level system. You will need to have TensorFlow and other necessary dependencies installed in your Python environment before proceeding. Here's an outline of the steps we'll cover in the notebook. Data preprocessing. Load the ASL fingerspelling dataset, preprocess the images, and split them into training and test sets. Model architecture. Define the architecture of the CNN model using TensorFlow's Keras API. Model training. Train the model on the training set using an appropriate optimizer and loss function. Model evaluation. Evaluate the trained model on the test set and calculate relevant metrics. Inference. Use the trained model to make predictions on new ASL fingerspelling images. To access the complete Jupyter Notebook code, you can download it from the following link. Please replace sandbox/path/to/asl_fingerspelling_recognition_with_TensorFlow.ipim in the link with the desired path where you want to save the notebook. Feel free to modify the code according to your specific needs and dataset. Remember to run the notebook cells sequentially to ensure proper execution and model training.
That's why it's like hallucinating stuff. It suggesting a link. There's no link. What? Like what link? I want to change this so it
An IPython notebook, IPYNB, is a file format and a web-based interactive computing environment for creating and sharing code, visualizations, and text. It is commonly used for data analysis, data visualization, machine learning, and scientific computing. IPYNB files are created and used with Jupyter Notebook, an open-source web application that allows you to create and share documents that contain live code, equations, visualizations, and narrative text. The term IPython in IPYNB comes from the original name of Jupyter, which was IPython Notebook. The IPYNB file itself is a JSON, JavaScript object notation, file that contains a serialized version of the notebook. It stores the code, output, text, and multimedia content all in one file. This makes it convenient for free research preview. Convenient for sharing and reproducing code and analysis workflows. IPYNB files can be executed interactively within the Jupyter Notebook environment, allowing you to run code cells and see the output immediately. This interactive nature makes it great for exploratory data analysis and experimenting with different code snippets. In addition to executing code, IPYNB files support rich text formatting using Markdown syntax. This means you can include formatted text, headings, images, hyperlinks, and even mathematical equations in your notebook. IPNB files have gained popularity in the data science and machine learning communities due to their versatility, reproducibility, and the ability to combine code, documentation, and visualizations in a single document. To work with IPNB files, you typically open them in a Jupyter Notebook environment or a compatible application like JupyterLab. You can create new cells, edit existing code or text, execute code cells, and save the modified notebook for future reference or sharing. Overall, IPNB files provide an interactive and flexible environment for data analysis, code experimentation, and sharing of research workflows. Regenerate response. Free research preview. ChatGPT may produce inaccurate information about people, places, or facts. ChatGPT May 24th version.
I was thinking eventually replacing Zoom. If anyone wants to join live these things, you're more than welcome to. This is why I do them. The main reason. The other reason is a bit of a diary. It's called research diary, lab book kind of thing, digital lab book. And the third reason is with all this AI code generation, it will be hard to determine, what was actually done by a human. So this is a bit of a evidence that a human was in the loop, was involved in creating whatever it is. I don't know, what is it we are creating? Well, currently trying to make this code work, recognizing a sign language spelling. So question is currently is I want to load this code alone into ChatGPT. Yeah, find the Copilot a bit hard to work with, like for the a whole code or large chunks of the code to be generated. So how do I interactive computer? Where's the Jupyter notebook? Question is do X. Wait a second, why we keep doing that? A win hedge should use more of this. How do I export the Python code out of Jupyter Notebook? Oh yeah, converting it into Py will be handy.
In Jupyter Notebook, you can export the Python code from a notebook in various formats, including a Python script.py file. Here's how you can export the code. Save the notebook. Ensure that you have saved the notebook with all the changes you want to export. You can click on the Save button or use the keyboard shortcut, usually Ctrl+S or CMD+S. Convert the notebook to a Python script. There are multiple ways to convert the notebook to a Python script. Here are two common methods. Using the command line interface, open a terminal or command prompt and navigate to the directory where your notebook is located. Then run the following command. CSS. Copy code. Jupyter and convert to Python your underscore notebook.ipython. Replace your underscore notebook.ipython with the actual name of your notebook file. This command will create a Python script with the same name as your notebook but with a.py extension. Using the Jupyter Notebook interface. If you prefer using the Jupyter Notebook interface, you can go to the File menu and select Download as -python.py. This option.
Why do I need to download? I'm running it live. Running this live. Can I save as Python file? I want to load it the whole code into ChatGPT. No. Not running it online. Download. Is there like an export? No. Save as. Yeah, I want to do Python. Doesn't have Python Py. Right, TensorFlow is Python. Failed to save. File name is not supported by. Let's make sure it matches the following. Yeah. So that is. Age, we're running that in the terminal. Oops. Waiting for more input. What's it called? In the wrong folder. No, we are in the correct folder. Getting an error. Oh, not generating. Oh, I meant this one. To be in the correct folder. We surely have Jupyter installed. To run everything from the scripts. It should have a Jupyter. Yep. Still wrong. No. That doesn't work. So we need to be in the folder of the notebook or in scripts. Should be the record, the notebook. How to export to Python code. Yeah, we just want the code so we can place it in here. VS Studio Code. Oh, come on. It's the problem, you're getting used to it too much, and then it stops working. You need to implement one locally. Probably use the llama.
To export Python code from a Jupyter Notebook in Visual Studio Code, VSC, you can use the built-in export functionality. Here's a step-by-step guide. Open the Jupyter Notebook.ipin file in Visual Studio Code. In the toolbar at the top of the VSC window, click on the Jupyter icon. The icon looks like a green notebook to open the Jupyter extension sidebar. In the Jupyter sidebar, you will see
Yep, my Copilot subscription have ended today. I thought it's tomorrow, but no, it's actually today. It's not working anymore, is it? Oops. Yeah, it's still working. It's using tab 9. So tab 9, I don't know if it's using AI or what's it doing, but it's using an auto complete as well. And it keeps asking, suggesting a pro version. Don't want to use it yet. What's in the toolbar on the top of the VSC window? Click the Jupyter icon. Where's the Jupyter? Yeah, let's check it in Bing, considering it's connected to the internet. There's an export button for. Yeah, so ChatGPT had outdated information. It says there's a Jupyter icon, whereas Bing says there's an export button on the toolbar, and I can't see it. Toolbar, what toolbar? Export button on the toolbar. Ah, here it is. Was hidden. Python script, right. Okay. Got the Python script. Let's save as show all files. Flow by. So we converted the Jupyter notebook into Python. We want to load it. How many? There's some errors. What? Right, it keeps doing that. I didn't think we had this. Back the expression, quick fix. So Copilot is not working anymore, is it? Failed to make request. Yeah, it's not running anymore. I think it just deleted. No, it's still. Oh, come on. One of five. What? One of five problems. Right, this thing is using Captain Stack. So this should be. And once you plot this, yeah, the Captain, was it Stack? Captain Stack. So it's searching Stack Overflow and found 10 different results. And you can scroll through them as such. So just a replacement of Copilot, a GitHub Copilot, where you actually have the link to the source code, which is great. So here's some examples you can find. Just as I think it just uses Google search to find results. That's pretty handy because it will give you the source, and you can go to the link, check what's the score, things like that in Stack Overflow for the code. So we will leave it for the meantime. We'll try using it later. At the moment we're just trying to fix. So we converted this code from Jupyter Notebook to Python. Basically things like a zip do not work. Can try quick fix. This is trying Copilot. Should we just turn it off? Right. Yeah, eventually we'll uninstall it. At the moment it's not working, we can disable it globally for now. Then I have to remember to get rid of it. We'll be using ChatGPT instead. We can place this in ChatGPT directly, see what it says. So I just need to set another set of headphones. I can't use those ones. So I have these ones are pressing on my head. Really expensive piece. Doesn't matter how expensive the headphones that I get, if it's just impossible to get something comfortable. Then I'm using this Jabras, so they are quite good. I kept dropping. This one was a more expensive version. I kept dropping them until one side stopped working. It actually does work, but much lower amplitude. And then I have this other one which I use with my phone, but now I want to use it for the stream. Probably be getting another pair, so I can use it for streams alone, and another one for the phone. Yeah, they break easily. The smaller they are, yes, they're comfortable. They don't fall out, but then they just fall out of your hands or my hands. I don't know. You obviously have some other problems with them. So just pair those with my PC. I forgot how to do it. I think you have to hold both buttons on both pieces for 5 seconds for it to go into pairing mode. Right. Add device, Bluetooth. Yes, that's the Jabra. The previous one I had the Elite 4. So this should be now connected. Let's check it out.
The error message you encountered, invalid character, \U21 in token, is related to Pylons, a language server used for Python in Visual Studio Code. This error typically occurs when there is an invalid or unrecognized character in your code or notebook. To resolve this issue, you can follow these steps. Check your code or notebook, look for any characters that might be causing the error. The \U21 in the error message suggests that there is an issue with the Unicode character at that position. Go to the line mentioned in the error message and inspect the characters near it. Remove or replace the invalid character. Once you identify the problematic character, remove it or replace it with a valid character. If you don't need that character, simply delete it. If it's a special character you intended to use, make sure you're using the correct Unicode representation or try using a different representation. Save your changes. After removing or replacing the invalid character, save your code or notebook file. Restart Visual Studio Code. Sometimes, the language server needs to be restarted to recognize the changes you made. Close and reopen Visual Studio Code to ensure.
Yeah, that's alright. Yeah. Object ready. There is a zip package or something. Import zip file, that's right. Yeah, I can sort this one later. I need to import zip file. How come? How come I didn't have to do it in the Jupyter notebook, considering it's also using Python? Yeah, NVIDIA broadcast when you connect new headphones or something doesn't recognize them, which is odd.
The above code, you import the zip file module and create a new zip file named submission.zip using the zip file constructor with the mode set to W for writing. You can then use the write method of the zip file object to add files to the zip file. Simply specify the path to the file you want to add as the argument to the write method. You can add multiple files by calling write for each file you want to include.
That's okay. That's fine. So we have this Python code. It's about almost 1,000 lines. Might have it really just take 1,000 lines. Yep, definitely did. Right. And then it comes up with an error message. So just tell me what's the maximum. What's the maximum like character length of characters, number of characters that you can take? The Jupyter notebook. Um, we need zip, zip. But we fixed this problem yesterday. Let's go all the way up until a prediction. We have the model and we want to use it. Yeah, let's use the back to the Jupyter notebook. Like a little, see a little red marker there, but it's nothing. There's no marker here. Yeah, I want to run it all the way up to training. Train model. This is where we split the data. This is standard split. What? So I made the code shorter, and now it says.
Unfortunately, the plot is missing from the provided code. Without the plot, it is difficult to understand the architecture of the transformer model being implemented in the code. The missing plot would have provided a visual representation of the layers and their connections in the model. However, based on the code provided, it seems that the transformer model includes components such as token embedding, landmark embedding layers for input encoding, transformer encoder layers for encoding the input sequence, and transformer decoder layers for decoding and generating the output sequence. The transformer encoder and transformer decoder layers use multi-head attention and feed-forward networks to process the input data. If you have access to the missing plot or any additional information about the model architecture, please provide it, and I would be happy to help further.
And how on earth do you provide a plot? Not sure which plot is it referring to, but well, now it should have some context. Right, this is better. But still trying to figure out what some of this code does. Well, we kind of know, but we would like more annotations as well. So like a summary or something. Where's the stop generating button? Yeah, this is the problem when you put it on a machine and it's like starts killing or something. Yeah, that button needs to be hardwired to the bot. It's interesting. Before it will try to like improve on the code. Now now it's explaining it.
The code you provided seems to preprocess a dataset by converting it into TF record format. Here's a breakdown of what the code does. It sets the length of frames to 128 using the frame_len variable. It checks if a directory named preprocessed exists. If it doesn't, it creates the directory. It iterates over each unique file_ID in the dataset_df data frame. For each
Right. This bit is important because we don't have to run it because we already pre-processed the data. We do have that directory present, so all this should not be executed. Now the thing is, what I don't understand is when you load the Jupyter notebook. Yes, if you start again, it sometimes memorizes those outputs. I think it's only when the text outputs. Yeah, this is probably all the variables. Variables in the Jupyter notebook. Sometimes it keeps generating forever. I was asking a generic thing, and again the stop generating button is absent. Yeah, so when you tell a bot to start, some crazy dictator tells an army of bots to start killing whatever. Ideally, it will be a big stop killing, stop executing button, but sometimes it decides not to have it, just removes it. That's not great. Oh, is it here? Yeah, right. It just before that button was in a different location. No, I'm more like how to monitor variables in a Jupyter notebook. Yes, you can print them, can display. Yeah, I think if you double click there, yeah, I think it's pretty safe to execute all the cell above this one. This is before training. Can hear my CPU going. The other thing wanna have to check if we have TensorFlow for GPU installed. Yes, it's still loading. So we have all these variables. Right, this one, like, where is it? JSON file. We already did the padding. Will it explain the code or try and... Yeah, why would you update it? I didn't ask to update. We want to explain.
The provided code performs the following steps. It opens a JSON file called character_to_prediction_index.json located at the specified path, c:\users/rtx/ASLFR/ASL-fingerspelling/character_to_prediction_index.json in read mode using the open function. The file is assigned to the file object f. The JSON.load function is used to load the contents of the JSON file f into a Python dictionary called char_to_number. This dictionary represents a mapping from characters to their corresponding numerical indices. The code then adds 3 additional key value pairs to the char_to_number dictionary. The keys are p, less than sign, and greater than sign representing the pad token, start token, and end token, respectively. The values are the corresponding numerical indices pad_token_idx, start_token_idx, and end_token_idx. Finally, a new dictionary called number_to_char is created using a dictionary comprehension. It swaps the keys and values of the char_to_number dictionary, resulting in a mapping from numerical indices to characters. The dictionary comprehension iterates over the key value pairs in char_to_number and reverses them, assigning the reversed key as the value and the reversed value as the key in the number_to_char dictionary. In summary, the code loads a JSON file containing a mapping from characters to numerical indices, adds 3 additional key value pairs to the dictionary, and creates a new dictionary that represents the reverse mapping from numerical indices to characters.
Yeah, this one, finding a dominant hand.
The code provided contains a function called pre_process that is used to preprocess data. Additionally, there is a helper function called resize_pad that is used within the pre_process function. Let's break down the code and understand its functionality. The resize_pad function takes an input tensor x as an argument. It checks the shape of x to determine its length along the first axis. A. If the length is less than frame_len, it pads x with zeros along the first axis to make its length equal to frame_len. B. If the length is greater than or equal to frame_len, it resizes x by keeping the same number of rows equal to frame_len and adjusting the number of columns based on the original shape of x. The resizing is done using tf.image.resize function. The function then returns the modified x. The pre_process function takes an input tensor x as an argument. A. It separates the right hand, right pose, and left pose from x using tf.gather function and assigns them to variables rand, land, repose, and pose, respectively. B. It calculates the indices where nan values are present for the right hand and the left hand using tf.math.is_nan and tf.reduce_any functions. The resulting Boolean tensors are assigned to nan_idx and nan_idx. C. It counts the number of nan values in the right hand and the left hand using tf.math.count_non0 function and assigns the counts to renans and lunans. D. Based on the comparison of renans and lunans, the code determines the dominant hand. If the number of nan values in the right hand, renans, is greater than the left hand, lunans, the dominant hand is the left hand, otherwise, it is the right hand. E. For the dominant hand. It extracts the x, y, and z coordinates of the hand. The pre_process function performs several operations to preprocess the input tensor x, including separating dominant and non-dominant hands, inverting coordinates, standardizing hand landmarks, resizing, and replacing nan values.
Just compare this to what the Copilot told us.
The code snippet provided defines a function called decode_fn that is used. Free research preview. The function takes a single argument record_bytes, which represents the serialized TF record example. It defines a dictionary called schema that specifies the expected features and their data types in the TF record example. For each feature column in feature_columns, it creates a variable length feature with a data type of tf.float32. Additionally, it adds a fixed length feature called phrase with a data type of tf.string to capture the phrase associated with the landmarks. The tf.io.parse_single_example function is used to parse the record_bytes using the schema. It returns a dictionary called features that contains the parsed features. The phrase feature is extracted from features using features, phrase, and assigned to the variable phrase. The landmarks for each feature column in feature_columns are extracted from features using tf.sparse.to_dense to convert the variable length feature to a dense representation. The landmarks for each feature column are stored as separate tensors in a list comprehension, resulting in a list of tensors called landmarks. To maintain the original shape of the landmarks data, the tf.transpose function is applied to the landmarks tensor. This operation transposes the tensor, swapping its dimensions. Finally, the function returns the transposed landmarks tensor, landmarks, and the phrase tensor, phrase. In summary, the decode_fn function decodes a serialized TF record example by parsing the example based on the specified schema. It extracts the landmarks and the associated phrase from the parsed features and returns them as tensors, with the landmarks transposed to maintain their original shape.
Can you visualize this somehow? Can landmarks and phrase be visualized? Want to have somewhere where you see the letter being spelled out and the phrase, like in karaoke.
Yes, landmarks and phrases can be visualized in order to understand and analyze the data. To visualize landmarks, you can plot the coordinates of each landmark point in a 2D or 3D space. The exact visualization technique would depend on the format and structure of your landmark data. For example, if each landmark has x, y, and z coordinates, you can create scatter plots or 3D point clouds to visualize the hand movements over time. Various Python libraries such as Matplotlib, Plotly, or Mayavi can be used for free research preview.
Yeah, we can ignore the z coordinate.
Regarding visualizing phrases, it depends on the nature of the data. If the phrases are textual labels or categories, you can create bar plots or pie charts to show the distribution of different phrases. On the other hand, if the phrases represent sequences or time series, you may visualize them as line plots or time series graphs to observe patterns and trends. Here's a simple example using Matplotlib to visualize the distribution of phrases.
So from decode function, a Python code to visualize let landmarks and phrases returned by decode function. So if it doesn't work,
To visualize the landmarks and the associated phrase returned by the decode_fn function, you can use libraries such as Matplotlib and NumPy. Here's an example Python code snippet that demonstrates how you can visualize the landmarks and phrase. In this example, the decode_fn function is assumed to be defined, and you should provide the serialized TF record example in the record_bytes variable. The decode_fn function will return the landmarks and phrase tensors. After decoding, the landmarks tensor is converted to a NumPy array, landmarks_np, for easy visualization. The code then plots the x and y coordinates of the landmarks using Matplotlib's plot function. Finally, the associated phrase is printed by decoding the phrase tensor using the decode UTF-8 method. You can run this code with your actual TF record example to visualize the landmarks and print the associated phrase. Make sure to have the necessary libraries installed, Matplotlib and NumPy, before running the code. Free research preview. ChatGPT may produce inaccurate information about people, places, or fact.
code function is Did I run this already? Okay.
You can run this code with your actual TF record example to visualize the landmarks and print the associated phrase. Make sure to have the necessary libraries installed, matplotlib and numpy, before running the code.
Keeps thinking. The free version do I have to pay? Make it faster.
Code Interpreter is now rolling out in beta on web, July 6th. We're rolling out Code Interpreter to all ChatGPT Plus users over the next week. It lets ChatGPT run code, optionally with access to files you've uploaded. You can ask ChatGPT to analyze data, create charts, edit files, perform math, etc. We'll be making these features accessible to Plus users on the web via the beta panel in your settings over the course of the next week. To enable Code Interpreter, click on your name. Select beta features from your settings. Toggle on the beta features you'd like to try. Browsing is temporarily disabled, July 3rd. We've learned that the browsing beta can occasionally display content in ways we don't want, e.g. if a user specifically asks for a URL's full text, it may inadvertently fulfill this request. We are temporarily disabling browse while we fix this.
What? Yeah, it's really weird, like the way it works. And why do I have a feeling if you pay for it, it would not necessarily be much better?
The value error you encountered indicates that you are trying to convert a value of type ellipsis to a TensorFlow tensor, which is not supported. The issue might be caused by incomplete code or missing data in your example. To provide a more accurate solution, it would be helpful if you could provide the specific code snippet that resulted in the error, along with the relevant context, such as the input data or the structure of the decode_fn function.
Do I have the decode fn function? Right, it's already predicted what my next question would be, which is nice. Wait, what? Okay. Uh, run this. Now, how come this haven't changed? Yeah, the code function is that. Need to get rid of this. Give us a different code. Why? Well, we're not losing anything. This one doesn't work.
Make sure you have the necessary dependencies installed, such as Matplotlib, to execute this code successfully. This code will display a heat map visualization of the landmarks and print the corresponding phrase. Adjust the visualization parameters according to your specific requirements. Apologies for the confusion. It seems there was an error in the code provided. To fix the value error regarding the unsupported type, you can modify the code as follows. Python. Copy code. Import matplotlib.pyplot as plt import numpy as npdef decode _fn, record _byte schema equals col, tf.io.varlen feature, type equals tf.float 32, for col in feature _columns, schema, phrase equals tf.io.fixedLength feature, type equals tf.string.
Why is it changing my... Is it changing my function? No, it seems to be the same. Yes, we do. We already import numpy. No, let's import it again. Don't want to do this. That's the same. Plotting landmarks. It didn't change anything, did it? Will it just plot one of them? For the whole phrase, you will need a video of it. Yeah, we'll comment this all. Comment this all out. Stop generating. The stop generating button was here. There was another one there. Now that one disappeared as well.
code snippet you provided creates a static hash table using TensorFlow's tf.lookup.staticHashTable function. This hash table is used to map keys to values. Here's an explanation of the different components. The initializer argument is set to tf.lookup.keyValueTensorInitializer, which initializes the hash table with a list of keys, values, tuples. In this case, the Google American Sign Language language fingerspelling recognition with TensorFlow. ChatGPT. Recognizing American Sign Language, ASL.
Because it's still generating. Question is, so this is something a Copilot, GitHub Copilot generated, this explanation. This is should be the same. Now the question is, if you put the code with its annotations to ChatGPT, is it getting biased by the annotations? Should you just put the raw code without annotations? Still generating or what? Not finished.
The code snippet you provided creates a static hash table using TensorFlow's tf.lookup.staticHashTable function. This hash table is used to map keys to values. Here's an explanation of the different components. The initializer argument is set to tf.lookup.keyValueTensorInitializer, which initializes the hash table with a list of keys, values, tuples. In this case, the keys are taken from the char_to_number dictionary's keys using list, char_to_number.keys, and the values are taken from the dictionary's values using list, char_to_number.values. This means that each key in the hash table corresponds to a value from the char_to_number dictionary. The default underscore value argument is set to -1. This specifies the value to be returned by the hash table when a key is not found. In this case, the default value -1 is used to handle out-of-vocabulary (OOV) tokens in the dataset. If a key is not present in the hash table, it means it is an OOV token. The name argument is set to class_weight, which is the name assigned to the hash table. Overall, this code sets up a hash table that allows efficient lookup of values based on keys. It will be used to convert characters, keys, to their corresponding numerical indices, values, for further processing or modeling tasks. Regenerate response. Browsing and search on mobile, June 22nd. We've made 2 updates to the mobile ChatGPT app. Browsing, plus users can now use browsing to get comprehensive answers and current insights on events and information that extend beyond the model's original training data. To try it out, enable browsing in the New Features section of your app settings. Then select GPT-4 in the model switcher and choose Browse with Bing in the drop-down. Search history improvements. Tapping on a search result takes you directly to the respective point in the conversation. iOS app available in more countries. Shared links in alpha. Bing plugin. Disable history on iOS, May 24th. ChatGPT app for iOS in more countries. Good news. We're excited to introduce a new feature, shared links. This feature allows you to create and share your ChatGPT conversations with others. Recipients of your shared link can either view the conversation or copy it to their own chats to continue the thread. This feature is currently rolling out to a small set of testers in alpha, with plans to expand to all users, including free, in the upcoming weeks. To share your conversations, click on the thread you'd like to share. Select the Share button. Click on Copy Link. Learn more. Bing plugin.
Hashtag Q, explain the code above. Hashtag A, the table is a static hash table that is used to map the characters to numbers. Hashtag the keys are the characters and the values are the numbers. Hashtag the default value is -1 for OOV tokens in the dataset. Hashtag the table name is class weight. Hashtag the table is used to map the characters to numbers. Hashtag the keys are the characters and the values are the numbers.
Yeah, this text-to-speech is not great, is it? This one is inbuilt, another add-on in Visual Studio Code. Whereas this one here is Bing's, Microsoft's. It's using Microsoft Christopher Online, natural voice. Yeah, now the free ChatGPT becomes super slow for me. It's something they updated recently. It was working fine before. Must have to pay for it. We prefer generating our own using Llama or something.
A static hash table is a data structure used for efficient key value lookups. It is called static because its content cannot be modified once it is created. Once the hash table is initialized with a set of key value pairs, those pairs remain fixed and cannot be added, removed, or modified. The static hash table typically uses a hashing function to map keys to indices within an underlying array. This allows for fast retrieval of values associated with specific keys. The hashing function calculates a hash value based on the key, which is used as an index to access the corresponding value in the array. Static hash tables are useful when the set of key value pairs is known in advance and does not change frequently. They offer efficient lookup times and can be beneficial in scenarios where constant time access to values based on keys is required. However, they have limited flexibility compared to dynamic hash tables, which allow for dynamic updates to the key value pairs. In TensorFlow, the tf.lookup.staticHashTable class provides an implementation of a static hash table. It allows you to create and use a static hash table within TensorFlow operations and models. 4/4. Regenerate response. Free research preview. ChatGPT may produce inaccurate information about people, places, or facts. ChatGPT May 24th version.
Right, it'll be interesting to see if I use Captain Stack. Right, well, this will generate it by tab 9. Are there more? Yes, because my GitHub Copilot is disabled. Yeah, this is tab 9. It generates in a weird way. Doesn't have a reference. The Captain Stack will actually give you a reference. Put it in ChatGPT, see what it says. So that means that ChatGPT is trying, like they seem to have all this internal teams at Microsoft, because it's all owned by Microsoft, isn't it? But they seem to essentially compete internally because of this code interpreter is a thing. Well, then is this a replacement for GitHub's Copilot? essentially GitHub Copilot is GitHub is obviously a separate team. Microsoft acquired them, I think, but they let them operate as they are.
ChatGPT plugins. We've implemented initial support for plugins in ChatGPT. Plugins are tools designed specifically for language models with safety as a core principle and help ChatGPT access up-to-date information, run computations, or use third-party services. Join plugins waitlist. Read document. Connecting language models to external tools introduces new opportunities as well as significant new risks. Plugins offer the potential to tackle various challenges associated with large language models, including hallucinations, keeping up with recent events, and accessing, with permission, proprietary information sources. By integrating explicit access to external data, such as up-to-date information online, code-based calculations, or custom plugin retrieved information, language models can strengthen their responses with evidence-based references. These references not only enhance the model's utility but also enable users to assess the trustworthiness of the model's output and double-check its accuracy, potentially mitigating risks related to over-reliance as discussed in our recent GPT for system card. Lastly, the value of plugins may go well beyond addressing existing limitations by helping users with a variety of new use cases, ranging from browsing product catalogs to booking flights or ordering food. At the same time, there's a risk that plugins could increase safety challenges by taking harmful or unintended actions, increasing the capabilities of bad actors who would defraud, mislead, or abuse others. By increasing the range of possible applications, plugins may raise the risk of negative consequences from mistaken or misaligned actions taken by the model in new domains. From day one, these factors have guided the development of our plugin platform, and we have implemented several safeguards. We've performed red teaming exercises, both internally and with external collaborators, that have revealed a number of possible concerning scenarios. For example, our red teamers discovered ways for plugins, if released without safeguards, to perform sophisticated prompt injection, send fraudulent and spam emails, bypass safety restrictions, or misuse information sent to the plugin. We're using these findings to inform safety by design mitigations that restrict risky plugin behaviors and improve transparency of how and when they're operating as part of the user experience. We're also using these findings to inform our decision to gradually deploy access to plugins. If you're a researcher interested in studying safety risks or mitigations in this area, we encourage you to make use of our Researcher Access program. We also invite developers and researchers to submit plugin-related safety and capability evaluations as part of our recently open-source devals framework. Plugins will likely have wide-ranging societal implications. For example, we recently released a working paper which found that language models with access to tools will likely have much greater economic impacts than those without, and more generally, in line with other researchers' findings, we expect the current wave of AI technologies to have a big effect on the pace of job transformation, displacement, and creation. We are eager to collaborate with external researchers and our customers to study these impacts. Browsing. Alpha. An experimental model that knows when and how to browse the internet. Motivated by past work, our own WebGPT, as well as GopherSite, BlenderBot 2, Lambda 2 and others, allowing language models to read information from the internet strictly expands the amount of content they can discuss, going beyond the training corpus to fresh information from the present day. Here's an example of the kind of experience that browsing opens up to ChatGPT users that previously would have had the model politely point out that its training data didn't include enough information to let it answer. This example, in which ChatGPT retrieves recent information about the latest Oscars and then performs now familiar ChatGPT poetry feats, is one way that browsing can be an additive experience. ChatGPT Browsing Plugin Demo 01:11. In addition to providing obvious utility to end users, we think enabling language and chat models to do thorough and interpretable research has exciting prospects for scalable alignment. Browsing up-to-date information. Safety considerations. We've created a web browsing plugin which gives a language model access to a web browser, with its design prioritizing both safety and operating as a good citizen of the web. The plugin's text-based web browser is limited to making GET requests, which reduces, but does not eliminate, certain classes of safety risks. This scopes the browsing plugin to be useful for retrieving information, but excludes transactional operations such as form submission which have more surface area for security and safety issues. Browsing retrieves content from the web using the Bing Search API. As a result, we inherit substantial work from Microsoft on 1. Source reliability and truthfulness of information and 2. Safe mode to prevent the retrieval of problematic content. The plugin operates within an isolated service, so ChatGPT's browsing activities are separated from the rest of our infrastructure. To respect content creators and adhere to the web's norms, our browser plugin's user agent token is ChatGPT user and is configured to honor website's robots.txt files. This may occasionally result in a click failed message, which indicates that the plugin is honoring the website's instruction to avoid crawling it. This user agent will only be used to take direct actions on behalf of ChatGPT users and is not used for crawling the web in any automatic fashion. We have also published our IP egress ranges. Additionally, rate-limiting measures have been implemented to avoid sending excessive traffic to websites. Click failed. You can block ChatGPT crawling your site using the robots.txt file. ChatGPT will show this error message when this happens. Our browsing plugin shows websites visited and cites its sources in ChatGPT's responses. This added layer of transparency helps users verify the accuracy of the model's responses and also gives credit back to content creators. We appreciate that this is a new method of interacting with the web and welcome feedback on additional ways to drive traffic back to sources and add to the overall health of the ecosystem. Code Interpreter. Alpha. An experimental ChatGPT model that can use Python, handle uploads and downloads. We provide our models with a working Python interpreter in a sandboxed, firewalled execution environment, along with some ephemeral disk space. Code run by our interpreter plugin is evaluated in a persistent session that is alive for the duration of a chat conversation, with an upper bound timeout, and subsequent calls can build on top of each other. We support uploading files to the current conversation workspace and downloading the results of your work. Code Interpreter plugin performing logic calculations. We would like our models to be able to use their programming skills to provide a much more natural interface to most fundamental capabilities of our computers. Having access to a very eager junior programmer working at the speed of your fingertips can make completely new workflows effortless and efficient, as well as open the benefits of programming to new audiences. From our initial user studies, we've identified use cases where using Code Interpreter is especially useful. Solving mathematical problems, both quantitative and qualitative. Doing data analysis and visualization. Converting files between formats. We invite users to try the Code Interpreter integration and discover other useful tasks. ChatGPT Interpreter Plugin Demo 03:25. Safety considerations. The primary consideration for connecting our models to a programming language interpreter is properly sandboxing execution so that AI-generated code does not have unintended side effects in the real world. We execute code in a secured environment and use strict network controls to prevent external internet access from executed code. Additionally, we have set resource limits on each session. Disabling internet access limits the functionality of our code sandbox, but we believe it's the right initial trade-off. Third-party plugins were designed as a safety-first method of connecting our models to the outside world. Retrieval. The open-source retrieval plugin enables ChatGPT to access personal or organizational information sources with permission. It allows users to obtain the most relevant document snippets from their data sources, such as files, notes, emails, or public documentation, by asking questions or expressing needs in natural language. As an open-source and self-hosted solution, developers can deploy their own version of the plugin and register it with ChatGPT. The plugin leverages OpenAI embeddings and allows developers to choose a vector database, Milvus, Pinecone, Drant, Redis, Weaviate, or Zillize, for indexing and searching documents. Information sources can be synchronized with the database using webhooks. To begin, visit the Retrieval plugin repository. ChatGPT Retrieval Plugin Demo 00:40. Security considerations. The Retrieval plugin allows ChatGPT to search a vector database of content and add the best results into the ChatGPT session. This means it doesn't have any external effects, and the main risk is data authorization and privacy. Developers should only add content into their Retrieval plugin that they are authorized to use and can share in users' ChatGPT sessions. Third-party plugins. Alpha. An experimental model that knows when and how to use plugins. Third-party plugins are described by a manifest file, which includes a machine-readable description of the plugin's capabilities and how to invoke them, as well as user-facing documentation. Schema_version, v1, name_for_human, to-do manager, name_for_model, to-do manager, description_for_human, manages your to-dos, description_model, an app for managing a user's to-dos, API, URL, /openapi.json, auth, type, none, logo_URL, https://example.com/logo.png, legal_info_URL, http://example.com, contact_email, hello@example.com. An example
Will this replace my manager? Your manager at work?
The steps for creating a plugin are: build an API with endpoints you'd like a language model to call. This can be a new API, an existing API, or a wrapper around an existing API specifically designed for LLMs. Create an OpenAPI specification documenting your API, and a manifest file that links to the OpenAPI spec and includes some plugin-specific metadata. When starting a conversation on chat.openai.com, users can choose which third-party plugins they'd like to be enabled. Documentation about the enabled plugins is shown to the language model as part of the conversation context, enabling the model to invoke appropriate plugin APIs as needed to fulfill user intent. For now, plugins are designed for calling backend APIs, but we are exploring plugins that can call client-side APIs as well. ChatGPT third-party plugins Demo 01:09. ChatGPT plugins developer experience 03:13. Looking forward. We're working to develop plugins and bring them to a broader audience. We have a lot to learn, and with the help of everyone, we hope to build something that is both useful and safe. Join plugins waitlist read documentation. Authors. OpenAI.
That's right. See what the difference between ChatGPT and Bing Chat. Bing Chat is obviously connected to the internet. Oh, it wasn't generating when I was on a different tab, was it? Oh, this is where the...
Skip to content.
Yeah, this is where... Oop. This is where the text-to-speech doesn't work at all. I don't know why. This text here.
Content.
It just says content. I have to copy it into another window.
ChatGPT. Examples. This line of code creates a static hash table object using the TensorFlow library. The static hash table is a hash table that maps keys to values. In this case, the keys are the characters in the char_to_number dictionary and the values are the corresponding numerical values. The static hash table is initialized with a key-value tensor initializer, which takes two arguments, a list of keys and a list of values. The default _value argument specifies the value to return if a key is not found in the hash table. In this case, it is set to -1. The name argument is an optional name for the hash table superscript 1. I hope this helps.
Yes, it does help.
Google, American Sign Language fingerspelling recognition with TensorFlow. ChatGPT. Recognizing American Sign.
This document must
Provide
be
a mapping between characters, keys, and their corresponding numerical indices, values, for the purpose of assigning class weights. It allows for efficient lookup of class weights based on characters during model training or evaluation. 3/3.
right. So we can get rid of it. That's what was suggested by tab 9. It's incomplete. Yes, it's obviously not as good as GitHub Copilot. Get rid of it for now. We have this class weight. So how does this table has a name, right? So it will be table.name, table lookup phrase. Convert function. So the name is not used. Lookup phrase. We tried. Ideally, when it's generating code, it should put the label, the request, the prompt on top. So this was search it like that. No, why not? Get rid of it. Right. So ideally, you would have this in the beginning of the function. I'll just save it as is. Well, yeah, that's what we're saving for. The idea of saving a file, transpose and apply masks. We just explained that code, didn't we? Well, yeah, this explanation is much better. Why sometimes? Right, that's okay. Setting up a hash table. Do I need to hit search for it to show table? Then it's doing a lookup phrase. We already explained this one before, didn't we? Let's do it again. Because we have a lot of time on our hands. Just kidding. Just kidding. So someone online on LinkedIn just mentioned that, yeah, they always say there's a lot of this hype. People say that it's ChatGPT AI, whatever, is making you as productive as 10 people. One average, someone said average person. So yeah, we all average, especially myself. So apparently I'm meant to be 10 times more productive. I'm like, yeah, I'm not sure. Well, not immediately, that's for sure. And as you can see from these latest updates to ChatGPT, they keep changing it as well all the time. So yeah, I think things will be very liquid, very dynamic, will change a lot of times. So I wouldn't hold my breath. And then it's one of those things that you will not be able to tell. Are you just more productive because you're more productive, or is it because of ChatGPT? Yes, maybe it helps you think better. For me, the obvious, one obvious advantage to it is that, yeah, I'm essentially using it as my co-host because I just don't have a human to do it for me because I don't have money to pay someone to do it. So yeah, this is a knockoff, a cheap version of a co-host.
The convert_fn function takes in two inputs, landmarks and phrase. Let's go through the steps performed in the function. Add start and end pointers to the phrase. The start and end tokens, start_token and end_token, are concatenated to the phrase to mark the beginning and end of the phrase. Convert the phrase to bytes. The phrase is converted to bytes using tf.strings.bytes_split. This step is necessary to prepare the phrase for lookup in the hash table. Perform lookup in the hash table. The lookup method of the table hash table is used to convert each character in the phrase to its corresponding numerical index. This step replaces each character in the phrase with its numerical representation. Vectorize and add padding to the phrase. The phrase is vectorized and padded to a fixed length of 64 using tf.pad. The padding is added at the end of the phrase with a constant value of pad_token_idx. This ensures that all phrases have the same length. Apply the pre_process function to the landmarks. The pre_process function is called with landmarks as input. This function performs pre-processing steps on the landmarks data, as explained earlier. Return preprocessed landmarks and phrase. The preprocessed landmarks and padded phrase are returned as the output of the convert_fn function. In summary, the convert_fn function converts the input landmarks and phrase into a preprocessed format suitable for training a model. It performs operations such as tokenizing the phrase, performing lookup in a hash table to convert characters to numerical indices, padding the phrase to a fixed length, and applying preprocessing to the landmarks.
I trust that is correct. I do not trust this thing. That tab 9 is generating. It's also odd. It's saying 37 files too. Otherwise, what's 37 files? That is the files in my folder. I have like 27 items. What are these 37 files that you speak of? Is it always 37 files? Seems like. don't know what is it doing. Right, this should be fairly self-explanatory, but we will ask ChatGPT to explain it anyway. Just because we can. Generating forever. Being any quicker. ChatGPT is still thinking. Being already generated quite a bit. And including a link, which actually works. It's a handy little link. Wait, did we change the batch size? No, I don't remember changing it. No, it should be okay. Don't like how it adding bits from the code into the explanation. You just write a standalone. Like, yeah, it's good to read, even though I can't read it. I can't read it out loud. I have to check it somewhere. Can actually check it into Word. So Word has a pretty good text to speech as well.
This code sets the batch size to 64 and then splits the dataset into training and validation sets. The training set is the first 80% of the dataset, train underscore len equals int, 0.8 asterisk len, tf underscore records, and the validation set is the remaining 20%. The train underscore ds and valid underscore ds variables are both instances of tf.data.tf record dataset, which is a class for reading data from tf record files. The map method is called twice on each dataset instance to apply two functions to each element in the dataset. The first function, decode underscore fn, decodes each element from its serialized form. The second function, convert underscore fn, converts each element to a format that can be used for training. The batch method is then called on each dataset instance to group elements into batches of size 64. The prefetch method is called with a buffer size of tf.data.autotune to prefetch elements from disk into memory in an optimized way. Finally, the cache method is called on each dataset instance to cache elements in memory for faster access during training. Captain stack. EEG downsampling temp equals 0.7. EEG downsampling refers to the process of reducing the sampling rate of an EEG signal. EEG signals are typically recorded at a high sampling rate, such as 250 Hz or higher, in order to capture the rapid fluctuations in brain activity. However, storing and analyzing such high-resolution data can be computationally demanding, so it is often necessary to downsample the data to reduce its size and make it more manageable.
It just keeps reading. No, I don't. Okay. That function not defined. Already was running it several times. code function. Right. Oh, we didn't actually run this. That was quick. This should be quick as well. Right. 1 second is okay. Now, yeah, I'll just say bye bye because we're meant to be finishing. I'll just keep going. If I don't say bye, it's because I already did. Yeah, it's funny that this is my YouTube analytics, and I think yeah, somebody already checked. You can show this data. It's funny how don't have much people watching live. But here for a sec, it's quite interesting. I do have while I'm live, I don't know if it's correlated or not, but people will watch some of the other content as well. This is what was watched previously. So like 3. This is last 48 hours. This last 60 minutes. I don't know. I was looking at it quite a bit. I don't know what to make of it. You have some people who are experts at this. Also wondering, exporting is not available for the current view. I don't know why. Anyhow, that's the normal. So this is what you get in your dashboard. It's suggesting you all sorts of things. Yes, across the almost 5,500 views for now. Can we make another subscriber during this live stream to round it up? I don't know if you get any extra perks for having 100. You definitely do when you have thousands, because that's yeah, when all sorts of when that's when you can become a partner. But I'm still obviously at 10% of that goal. You can see your content, some of my lives. Yeah, you can see here this live. Interestingly, I think the algorithm started promoting it, just showed it to quite a lot of people. You can see the analytics, yeah. So within the first, and then it's not doing much past that point. So that's obviously algorithmic, not quite synthetic. Whereas I can show you some of the videos. So if you go by views, yeah, so you can see this is what's called the all evergreen content. That's where it's always getting views. This is since published, and you can see a stable increase. This is not the algorithm promoting it, but it's a short video, and it was watched overall for over 4 hours, which is great. Didn't take much long to produce. You can see watch got 7 subscribers out of it. Yeah, you get your reach analytics, so the number of impressions, so essentially how many people this video was offered to. Click-through rate, my understanding, this is quite high. Normally would be around 2%. And this is where people found the video from, so on and so forth. Yeah, there's a lot of this kind of stuff. This content suggesting this video. What's that? I haven't seen this one before. Oh, I think it's Ava content on the channel that's at the end is suggesting this video. I think, I'm not sure. Maybe go back to. Oh, come on. What? Yeah, there's a there's a lot of stuff. I can't get back to the analytics. Yeah, so interesting when I'm live, there are other people watching, but not the live stream. They sometimes will watch the live stream after it finished, but they will actually watch our content, interestingly enough. This is when we took some holidays. So yeah, the algorithm kind of forgets about you. It stops promoting you. Theory. Yeah, impressions. So it's yeah, it stops suggesting your videos. So you have to kind of, essentially the algorithm, it keeps nudging you to produce more content for it to, recommend it to viewers. And yeah, that's the overall click-through rate, which is quite important. It fluctuates quite a bit, but yeah, average of 2.5%. Obviously, view duration is very important. That's where that at. But yeah, so I have to finish up. We'll continue tomorrow on this code. Hopefully, we'll train. We already trained the model, trying to figure out how to actually use that a model file, and we'll go from there and try to improve on it, because at the moment it's essentially only like 50% performance. So ideally we'll go all the way to 0 with a loss function, so we have less false positives and incorrect identification of a sign language prediction model. So I'll see you next time. Bye.